Good evening, everybody. This work is being done by all my colleagues, Dr. Venkatesh, Dr. Lata, and the team. This is a bit on the technology part, how technology can be used for the science. So I will just give the need for Arctic mooring, some mooring details, how the deployment retrieval was done, and what are the parameters measured there, and something on ambient noise measurement. This is being done for the first time, and the qualification of the moorings and the data analysis and control. If you see here, I think this aspect is very well known, that Arctic region received lot of attention, and I don't want to go into these details now because it is very well understood by this esteemed forum here. And we require a lot of measurements in this region. As some other speakers have mentioned, how there is the teleconnection between Arctic and Indian monsoon, and how the acoustic observations can give valuable information. So it is found that it is necessary to have a lot of measurements here, especially in the Arctic fjords. And for this, long-term observations are required. It's not sufficient that we do it for one season. So for this, we have I'm just giving as an introduction how the Arctic sea ice volume has changed. Of course, this is taken, I have given the reference here. So I was wondering that I am almost the penultimate in the session. Till now, nobody has shown this, which is taken from the literature. So this gives a very bad indication, how from 1979 to how it has come till 2014. Of course, further data is not yet updated in this. And you can also see how the Arctic sea surface temperature has changed. And Dr. Rajan had already said that how Arctic will be without ice after some time, how it will look like. It's really a problem which we all have to really attack. So if you go to the region of Kongstradon, there is necessity to measure the parameters there, because you know that all the carbon dioxide is taken to the ocean, and we, NIOT and as well as NCOR, we had a good team working. Dr. Rajan was the director at the time, and NCOR and I was at NIOT. So we had a joint team, and a mooring was designed, and 23rd July 2014, for the first time, the team had a mooring established at this particular location, about 192 meters. You can see this is the location, and this is a photograph of that. You can see some bathymetry also was done in this region. And you see, this is the mooring layout. It consists of lot of instruments, CTD at various depths, and we had ADCP, acoustic Doppler profiler, that is, it measures the velocity profile, and this is actually kept in place by a mooring, and there is a dead weight, and there is an acoustic release, and the top there is a float, and there is an Argo float here, and it is loosely connected so that in case of any ship movement, even if it hits, it will only hit this portion and it comes up and we know that it has been hit. And when it is alright, after 1 year, you can go there and give a signal to this acoustic release, and this gets disconnected and the whole thing floats up, and we pick it up using the ship. You can see that this is the team, NCR and IoT team, which deployed that. This is the deployment of this, it's called named as IndARC. And these are some of the pictures of the retrieval of this mooring after 1 year. It was really a challenging task, because people from India, especially from the southern region, experience only hottest temperatures, and anything less than 25 degrees is really freezing for us. So how our team went there in this condition and did it is really a challenging task. And you see that these are some of the data that is recovered. Of course, this was done in the subsequent years also, 2014 and 15. Temperatures at various depths of 22 meters, 30 meters, etc. This is how the temperature profile is in that location. And we also had the current speed at various depths here. It is plotted here. You can see that current speed in millimeters per second in the 2014-15, 2 years of the mooring. And a lot of analysis is being done on this. And this is a at another depth of 25 meters, the current speed variations. And you see that we found that the temperature and salinity were obtained at these depths from July 2014 to 15, and they were showing an annual cycle with maximum of 7 degrees in August and minimum of minus 1.5 degrees. The salinity range was about 3.6 to 35.1 PSU, with drastic changes in August-September, which dropped about 2.7 PSU. Another lower salinity was in November at depths of 55, 80, 105 and 130 meters. The DO, the dissolved oxygen also was measured at 22 meters, and the minimum was about 6.6 milliliter per liter, and maximum in May about 9.5 milliliter per liter. So the oxygen content in the water has increased drastically in the month of May. And continuing with the analysis, we found that the fjord waters were well mixed during the December to April. Then of course there is a strong current during May, which suddenly increases the oxygen content, and thereafter again it gets stratified. Of course the zonal, meridional and vertical currents were obtained, and strong westerly currents were noted in September and May. And this also coincided with a strong northerly and positive entrainment as represented by the middle and the bottom panel, which I showed slightly before. And you see that we also compared with another mooring of Norway named Nortec, an ADCP at 25 meter depth, and we had a good correlation with that value also. Subsequently, we put up moorings at in 2015, 16 and 17. 17th one is just continuing. You can again see now we have become, so to say, we can claim that we have become experts in putting mooring in the Arctic region. I think I should place on record the support given by the Norwegian Institute for this purpose, because they had really given us the ship time and also the people and also the weather forecast, everything they did with us, and we worked completely as a joint team. So I would really like to thank them for all the support given. And you can see that after some time we started increasing the payloads. In the latest ones we have got the pressure and optical method of measuring the dissolved oxygen. All these instruments we have put up, and we also put an noise measurement system, which I will come to soon. And you can see that this is the retrieval of IndARC 3 mooring and the deployment of IndARC 4, this last one, the latest one, so to say. The deployment has been done, and we expect to go there next year and take it out. And this is the data for all the from 2014 to 17, the water temperature at various depths and the salinity at various depths have been given. And as some other presenters said, we require students working in this area to please use this data and come up with a lot of results, because we working in a R&D institute, we have got our own limitations with our projects working, etc. So we may not get full time to do this analysis, etc. So this data is available at no cost and no effort. You have got it. So please utilize this data and come up with good results. Now I'll move on to the ambient noise measurement in this region. So this ambient noise measurement, we have been doing it in the other seas, in the Bay of Bengal, in the Arabian Sea, etc. So here we again want to do it in the same location of Kongstedon, that is again as part of the same mooring. And there has been lot of work done in this fjord, and ambient noise varies temporally. And also, depending upon the geophony, there is ice melting, ice carving, biphony, and that is due to marine mammals. and anthrophony, that is the ship and vehicle, which are the vessels which are moving through that location. And you see that the design of the system of the data acquisition, etc., has to be done very carefully because of the environmental conditions, and the subsystems have to withstand that. Compared to the other mooring which we did, where we procured the systems from the readily available market, here we have designed our own system, and that required a lot of testing, etc. So we had put it like Dr. Ramdas said about the polar ROV. In this system, the data acquisition system, etc., everything we designed, and we had put in the environmental chamber and tested it up to -4 degrees centigrade. And we also did periodic measurements in the Kongsvedon region before putting it into the mooring. And it was also tested for the receiving sensitivity, etc., in the acoustic test facility which is available at NIOT. So this is a test that is going on there to see that it measures the right values. And these are some of the data acquisition parameters. The hydrophone was Cetacean make, and we had a frequency range of 8 Hz to 100 kilohertz. It was put at a depth of 30 meters. Even though the ocean depth was 190 meters, we put it at 30 meters. You can see that it's the same mooring, but you can see that a circle here, maybe that is not very clear. This is a hydrophone where the measurement of the ambient noise was made. And of course, this is a location, the same region where I explained the other mooring is put in IndARC mooring. It is a part of the same mooring. And you can see some of the spectrogram of this data which was acquired. And we have to remove the generator noise because the ship has got a generator, and the propeller, other man-made noise, self-noise, etc. have to remove. We had some publications also in this Elsevier publication. And you can see the spectrogram here with frequency time. And you see that there is a iceberg carving and iceberg bobbling noise which has been measured here. You see that it has got an exceptional noise environment. Ice cracking noise can be seen here. You can see that this region is the ice cracking noise at a frequency of 200 between 200 300 hertz, etc. So this is one important way in which you can analyze and find exactly where when the noise, the ice cracking starts. These are all indicators for climate change. Of course, this has to be done for a long period of time. So it varies depending upon the condition, the thermal condition, the thermal expansion of the ice and things like that. And if you see, this is the period. Of course, we had it only on the last year, that is 15 to 16. We had about 2000 data sets, and each interval sampling for 60 seconds is taken, and it is averaged and for 3 hours. And the ice carving noise alone is taken. You can see that this is the spectrogram of that. And if you see that anthrophony is a growing concern here in the marine environment, which is adversely affecting the marine life. That is due to shipping, commercial vessels, etc., and propeller cavitation. And this is normally less than 1 kilohertz. Many of the container ships which will have the peaks near 0.4, 0.7, 1 kilohertz. And there are also narrower peaks sometimes at 2 kilohertz and 3 kilohertz. And you can see that there is a ship noise that is generated, as I explained about. It's been recorded in that particular location. And also this biphony is very important because this is walrus. These are taken from the literature. They are highly sociable and ice breeding special mammals, and it can go up to 250 meters, and also it can come to 80 meters. And mating will take place in the water and in open water also. They produce different types of patterns during breeding, such as knocking and tapping, etc. I will just make you listen to that for some time. And the knock and taps of various frequencies are there. Maybe I'll just show it. You can hear this now. So I would like to conclude now. One of the important things is that we have to measure this data for a very long time in the Arctic, so that long-term climatic variations can be studied. A lot of hypotheses are there, and conclusions from other observations can be validated by this means. Only thing is we require a lot of support from our ministry, especially funding. This is a very expensive proposition each year, going to Arctic and setting up this thing. And we require full support from the Norwegian counterparts, which I am sure that it is always available. And we want to put systems that can work for longer periods, not just 1 year, each year going and taking it back. Maybe we should have some way of online transmitting the data acoustically and through satellite or something like that, so that every year we don't have to go and measure this. So with this, I come to the end of the presentation. There were some more audio files, but due to lack of time, I am not showing it yet. Thank you very much.